Hello everyone. I'm going to discuss a new topic. So this is the previous slide I have presented. Okay. So this is about Poisson's distribution. Uh, Poisson's distribution. Which is a topic about discrete probability distributions. So we now proceed with our next topic, which concerns about continuous probability distributions. So in my discussion before, I have already introduced probability distributions, and there are two types of probability distributions. One is discrete and the other is continuous. Okay, so for a discrete probability distribution, the random variable is discrete. For a continuous probability distribution, the random variable is continuous. No? So a continuous probability distribution is a type of probability distribution with a continuous random variable, and such distribution cannot be constructed in tabular form because it is continuous because the random variable is continuous. Okay, we cannot construct the distribution in tabular form. No, we cannot do that because all possible values are infinite, no? All are infinite in number, no? All the possible values of the random variable, no? Hindi naman natin masusulat lahat ng mga values ng mga random variable kasi lahat ng decimal numbers kasama dyan. Okay? So, as many points as a line segment, no? Kasing dami ng mga points sa line segment, ganun karami yung mga values ng random variable. Pero we can represent the distribution in terms of a formula or a graph. No? We can represent the continuous probability distribution in terms of a formula or a graph. Okay? Now, here's the graph of a normal distribution. This is a normal distribution, which is a type of probability distribution. No? So this is which is a type of continuous probability distribution. No? And as shown in the figure, we have bounded areas below the graph. No? So we have the areas below the graph. So we have bounded areas. No? So from A to B, lower limit A, higher limit B. Okay? Now this area represents probability of the continuous random variable x. So this is our random variable which is continuous. No? So in other words, we consider all the points now from this axis. We consider all the points. Considering all the points, now that includes integers, decimal numbers, which is as many as the points in a line segment, no? So which is infinite in number, no? So we have infinite number of values of this random variable x. Okay. Now the random variable no has a value of a and has also a value of b. No, between the two, no, between the two, between a and b. So there is area now below the graph. So this is the graph of a continuous probability distribution. Okay, and from x equals to a to x equals to b, there is now area, and that area represents the probability. No? So the probability that the random variable x is between a and b. No? So the probability that the random variable x is lies between a and b, okay, represents this area. Okay, so in that case, there is something to consider here. So the probability that the random variable x is between a and b, no? Or should I say the probability that x is greater than a but less than b is the same as the probability that x is greater than or equal to a but less than or equal to b. So for a continuous probability distribution, these two are equal. No? So what's the reason behind that? Note that the probability that when the random variable is exactly equal to a, the probability that the random variable is exactly equal to a is 0. No? So that is 0. Okay? That is, why is it 0? So this is only 1. 1 out of how many possibilities are there? Infinite number of possibilities. So this is infinity. And 1 over infinity, that is uh, that will approach 0. No, 1 over infinity will approach 0. Okay, because there are infinite values for x. There's only one value for x to consider, a. So that is 1 out of infinity. Okay, 1 out of infinity. Okay, so that will now be 0. No? So the probability that the random variable x is exactly equal to a is 0. So as you notice here, when it is exactly a, there's no area because there's no width. There's only length, but there's no width, right? So if this is a rectangle, the area of a rectangle is length times width. If there's no width, if the width is 0, whatever value of L, which is the length of the rectangle multiplied by 0 is 0, right? So in that case, so there will be no area. If there is no area, the probability that the random variable x is equal to a is 0 because the area represents probability. No? This area represents probability that it is exactly equal to a. And since there's no area, because there's no width, the probability is then 0 because the area is 0. Okay? So take note of that. So, which has the same numerical value as the area below the graph. No? So, the probability that x is greater than a but less than b is the same as the probability that the random variable x is greater than a is greater than or equal to a but less than or equal to b. Okay? Whether we include A or we exclude it, still the same. The probability remains the same because the probability that the random variable x is exactly equal to A is 0, same as B. The probability that when the random variable x is equals to B, the probability that it is exactly equal to B is also 0 because there will be no area formed. So which has the same numerical value as the area below the graph. So this one and this one are equal whether we include A or not, whether we include B or not. No? So because the reason is the probability that the random variable x is exactly equal to A is 0. Likewise, the probability that when the random variable x is exactly equal to B is equals also to 0. No? So that's the property of a continuous probability distribution. Okay, so this is now the area in integral form. Okay, so you have studied calculus, and in order to find the area below the graph, now bounded, so bounded area, we have here bounded area from A to B. So the integral of the function, so this is now the function, so this has a certain equation. No, this curve has a certain equation. F of x is equals to blank. Okay, it has a certain equation. So we substitute the the right hand side of the equation in this formula for area, and we integrate it, no, over the range, no, from A to B. Okay, so doing that, okay, we'll find this area. Okay, we'll find this area. So I think napag-aralan nyo naman siguro yung area between two curves sa integral calculus, right? So no need to elaborate this. Okay, so we now proceed. So we have here the illustration. So f of x is called the probability density function. No? F of x is called the probability density function. So when we are referring to a continuous probability distribution, we call f of x as probability this density function, no? Or simply density function, no? Of the continuous random variable x, no? Okay, and then f of x. So this is a property of this distribution. F of x is greater than or equal to 0 for all values of x, an element of the set of real numbers. No? So in here, this notation indicates the set of all real numbers, which includes rational numbers and irrational. No? So and also when if we analyze this equation, f of x greater than or equal to 0, okay, it will never be negative. That's interpretation, right? F of x can never be negative. It's always 0 or positive. Okay? So, in other words, it can be exactly 0 and greater. So there's no graph below it. No? There's no graph below because that indicates negative value of f of x. So that is not allowed. So this is the condition that f of x is 0 or a positive number. No? So that's the property of a continuous probability distribution. Now, the probability that the continuous random variable x is exactly equal to a value x is 0, as I have discussed earlier, okay, because no area below the graph is obtained. So thus, this is now the illustration, okay, probability that a random variable x is exactly equal to x for a continuous probability distribution is 0. No? So the total area below the graph of a continuous probability distribution is equal to 1 square unit. So take note of that. That is another property of a continuous probability distribution. The total area below the graph is equivalent to 1 square unit. Or should I say is equal to 1 square unit, which is equivalent to a probability of 1. So that is the interpretation. No? So thus, we have the probability that the random variable x, okay, is between negative infinity to positive infinity. From negative infinity to positive infinity. Okay? So the probability is therefore equal to 1 because the total area from negative, if we integrate the function, okay, f of x dx, from negative infinity to positive infinity, that will be 1. That is the property of a continuous probability distribution. Okay? So let's now talk about the normal distribution. So when we talk about normal distribution, it is a continuous probability distribution. No? It is a continuous probability distribution. It is also known as Gaussian distribution in honor of Carl Friedrich Gauss. Okay? So in here, normal distribution uh, is very useful, no? Especially in when conducting uh, data analysis. No? So when we perform data analysis, this is very useful. No? Okay? So when we go to chapter 5 and we proceed to chapter 5, okay, we can apply this topic. Uh, and also in your research subject, no? In fourth year, you can apply this, no? This topic. So let's now talk about in detail about this topic. So we have a normal distribution is a continuous probability distribution. It is also known as Gaussian distribution in honor of Carl Friedrich Gauss, who lived from 1777 to 1855. Okay, now its density function is given by the formula. So this is the formula. Okay, so we have f of x is equal to 1 over, so this is the Greek letter sigma. Okay, Greek letter sigma. Okay, sigma square root of 2 pi multiplied by e negative 1 half multiplied by x, which is the random variable value, okay, minus the mean, okay, mu, Greek letter mu, okay, over sigma, then we square. Okay? Or okay, so this has interpretation. When we talk about sigma, we call it the standard deviation. So this is called standard deviation, okay, of the population. Standard deviation of the population, okay, and this one, mean, okay, we call it mean of the population, okay, mean or average, right, of the population, mean of the population, okay. I think you're familiar with these symbols, no? You have learned this in mathematics in the modern world subject, right? Okay. And then we have E. So you know pi is 3.1416 and so forth, right? So E is 2.71828 and so forth. Okay? So that is E, which is in the calculator. Now we have here, so this is the graph. This is the graph of a normal distribution. No? So this is it has certain property that I will discuss later. No. So where x is equals to value of the random variable of the normal random variable. Since our random variable has a normal distribution, therefore we call the random variable now as normal random variable. No. So the random variable x, which is a normal random variable. Then we have sigma, the standard deviation of a set of data. No? Then we have mu, the mean of a set of data. No? Okay. So this is the property of a normal distribution. So if we analyze, this is the center, there is symmetry. No? There is symmetry about the vertical. No? Wherein we have mu is the mean. About the vertical axis, there is symmetry. So we have mean. Now we have here standard deviation. So when we add one standard deviation from the mean, we add one standard deviation. So we have mu plus sigma. That is already 34.1%. Okay, meaning that is this is about 0.341 square unit of area. No? Or should I say this represents a probability of 0.341. Okay, if from the mean, okay, we add two standard deviations, so we add 13.6% additional, so plus 0.136, so we shall get what, 7 uh, 47, then 0.3.477, right? 0.477, isn't it? There. 0.477. Okay. Okay. So that's it, no? And then plus 2.3%. Okay. So plus 0.23 plus 2.3%. So 0.477, then 0.023, right? That is 2.3%. 10, 10, 5, 0.5. Okay? So meaning this is already 50%. The other 50% is to the left, no? 34.1%, 13.6%, 2.3%. So if we add the two, that's 100%. Okay? So meaning that is equivalent to 1 square unit of area, which is a probability of 1. Okay? So that's one characteristic of a normal distribution. Okay? The total area below it is equal to 1 because it is a continuous probability distribution. Okay? And we proceed. So properties of the normal distribution. Okay, as I have said earlier, the area under the normal curve is equal to 1 square unit, which is equivalent to a probability of 1. Okay, the normal curve is symmetrical about the vertical axis through the mean. So this is the vertical axis through the mean. Okay, it is symmetrical. No, the normal curve is symmetrical about the vertical axis. So this is the reference axis. No, this one. Okay, it is symmetrical. Okay, so there is symmetry about the vertical axis through the mean. So this is the mean. The normal curve will not intersect the x-axis when the curve extends indefinitely. So another property, it will not intersect the x-axis. So although dito parang naka ano siya, 'di ba? Naka intersect. Pero kung pero hindi naman talaga siya naka ano sa x-axis na saktong zero, no? Hindi siya saktong zero. Kumbaga, kahit basta hindi siya magsasaktong zero, maraming zero, then 1. Halimbawa, o dagdagan pa natin, basta hindi siya magsasaktong zero. Kaya dito, siyempre, mukha siyang sakto, pero pag i-view natin siya ng i-view natin siya sa, should I say, microscopic view. So, kung i-microscopic view natin, okay, meron pa yan, gap, makikita mo, no? Okay? So, in this case, basta hindi siya pwedeng magsaktong zero. Yun ang kanyang property. Okay? So, the normal curve will not intersect the x-axis when the curve extends indefinitely. Pagka nag-extend pa yan, hindi siya magsasaktong zero. Okay? Pero malapit sa zero. Pero hindi pwede magsakto. Yun ang kanyang property. Okay? Kung ano pa natin yan. Analyze natin. Kung extend pa natin. No? Alright. So, we proceed. So, we now proceed with the standard normal distribution. Okay? So, for the standard normal distribution, so this is the similar to the normal distribution. Okay? That I have introduced a while ago. Okay? Pag sinabi nating standard, meron tong property, special property. No? Hindi lang siya normal distribution. Ordinary. Hindi siya ordinary normal distribution. Okay? So, standard normal distribution siya. So, meron siyang kaparehong property dun sa normal distribution na pinakita ko kanina. Okay, eto halimbawa, ito 34.1, yan pa rin, mananatili yan. Mananatili yan. Okay? So, this is 68.3%, 95.4%, 99.7%. Okay? So, kumbaga, nawala na yung ano dito, mu. Nawala na yung mu plus sigma. Ito, mu minus sigma. Mu minus 2 sigma. And so forth. Napalitan ng mga values. Yun ang pinagkaiba niya ngayon sa normal distribution na tinuro ko kanina. So the standard normal distribution is a normal distribution with the mean of 0, and a standard deviation of 1. Kaya naging ganito siya. So, yung mean daw natin ay 0, that is now mu 0. Standard deviation ay 1. Sigma ay 1. So, therefore, 0 na to, kaya 0 yon. 0 plus 1. 0 plus 1, kaya 1. 0 minus 1, no? Kaya negative 1. 0 minus 2 times 1, kaya negative 2. And so forth. Kaya ganun siya, no? Okay? So, whose density function is given by the formula. So, ito na, na-simplify na siya. F of z equal to 1 over square root of 2 pi e to the negative 1 half z squared. Okay? Yung kanina kasi, so kung mapapansin nyo, ang ating random variable ay z na, hindi na x. Okay? Tapos f of z. Yung function. Yung density function natin. So, in this case, yung kanina kasi, ganito siya. F of x, 1 over sigma square root of 2 pi, okay, e, negative 1 half, x minus mu over sigma squared. Ganyan siya, right? So, dahil ang sigma ay 1, kaya naging square root of 2 pi na lang siya. So, f of z, ayan, nawala yung sigma, naging 2 pi. No? Naging 2 pi na lang. So, yung x, napalitan ng z. Okay? So, tuturuan ko kayo mamaya kung paano magpalit from x to z. So, yung f of x, magiging f of z. Okay? Provided na yung sigma magiging 1. So, square root of 2 pi na siya ngayon. Okay? Tapos, e, negative 1 half. Yung x minus mu over sigma, z yan. So, mapapalitan niya ng z. Z value. Tapos, square natin. Ayun, ganun lang pagkakaiba niya sa ordinary normal distribution. Okay? So, x minus mu over sigma. Okay? So, alright, so we proceed. So, to convert a normal distribution to standard normal distribution. So, this is the formula. So, we will apply this formula. Z is equals to x minus mu over sigma. Okay? So, z is the value of the standard normal random variable z. Mu is the mean of a normal distribution. Okay? Sigma is the standard deviation of a normal distribution. X, lowercase x, equals to the value of the normal random variable x. Okay? Okay. So, here's the curve. No? So, and then, here's the curve and the table. So, in here, we'll apply this table to solve for the area, or should I say the probability of interest, no? So kung ano yung ating hinahanap na probability sa problem, gagamitin natin to. Areas under the standard normal curve. Okay? Kasi z siya naka-z. No? Okay. So, bibigyan ko yung halimbawa na, let's say, ang z ko ay negative negative 2.9, sabihin niya negative 2.93. Sabihin niya negative 2.93. Yun ang aking z. So, negative 2.9.03. Sabihin niya negative 2.93. Okay? So, negative 2.9 tsaka negative 0.03, negative 2.93 pag pinag-add mo yung dalawa, right? So, in here, we have 0.0017. So, yun ang intersection nila. Ito, tsaka yun. 0.0017. So, anong interpretation yan? So, the probability, okay, so sabihin yan, so, yan ay negative 2.93. Sabihin niya, yung area na yan ay 0.0017 square unit. Okay, yan yung area niya. 0.0017 square unit. So, ganun yung interpretation. Area to the left. Area to the left. Okay? So, another example. So, itong 0.0017 na yan. No? So, yan yung probability na yung ating random variable z ay less than negative 2.93. Sabi nito, area to the left. No? Area to the left. No? Z, ang ating random variable, kasi meron tayong random variable z. So, small letter z, value ng random variable. So, sabihin nito, pag ang ating random variable z ay mas mababa pa sa negative 2.93, yun yung area na tinutukoy, yung mas mababa pa sa negative 2.93. Diba? So, nandito yung ibang value na mas mababa pa sa negative 2.93. At yung area na yon, yun yung 0.0017. So, yun ang sagot na probability. 0.0017. Okay? So, that's it, no? Okay. So, ibig sabihin nito, no? Probability, random variable z is less than the value z. Okay? So, ganun siya. O, bigyan natin ng ibang example. Okay? Positive naman yung mga value. Ito. Ating continuation. Positive naman. Sabihin natin 1.30. Ito. 1.33. 1.33. Ito yung 0.9082. So, kung yan ay 1.33, okay, if that is 1.33, 1.3 plus 0.03, 1.33. So, this is now the area. The area to the left is 0.9082. Okay? So, this is the probability that the random variable z is less than 1.33. Okay? Kasi meron ka ditong random variable z na mas mababa pa sa 1.33, that is area to the left, that is equals to 0.9082. 0.9082. So, sabihin yan, 0.9082 square unit, yun ang area na to. Okay? So, 0.9082. Okay? So, that's it. So, ito yung area ngayon. Alright, so, let's answer an example. No? So, we have problem solving on normal distributions and standard normal distributions. So, given a standard normal distribution, find the area under the curve that lies to the right of z equals to 1.84. no? And between z equal negative 1.97 and z equal to 0.86. Okay, so ito yung solution. So find the area under the curve that lies to the right of z 1.84. So ito yung hinahanap. So ito yung ating z 1.84. Ito yung graph ng standard normal distribution natin. We are to determine the area under the curve that lies to the right of z equals to 1.84. So ito yung ating 1.84 na z. Okay, ito yung 1.84 na z. Okay, so ito yung nahanap ngayon natin. Okay, find the area under the curve that lies to the right. So ano yung area na to? Okay, that lies to the right of z equals to 1.84. Solution to the problem from table 8.3. So table 8.3, hanapin natin yung 1.84 na. Hanapin natin yung 1.84. So ito yung concern natin, no? Probability, kasi sa table 8.3, ganito yung illustration, right? Ganyan. Ito yung z, tapos ito yung z, tapos ito yung area, no? Ganyan. Ngayon, laging area to the left yung ibibigay ng table. Laging area to the left. Okay? So kung ganon, mag-a-adjust tayo. So kukunin natin ano yung area to the left nung may z na 1.84. Okay, ano yung area to the left considering z equals to 1.84. So, base sa table, ang lilitaw ay, so by the way, pag sinabing probability z greater than 1.84, ibig sabihin yan, area to the right nung z na 1.84. Area to the right kasi greater. So ito ay area to the left, so less than. Less than nitong 1.84 na to. Okay? So area to the left yung may less than. Area to the right yung merong greater than. So ibig sabihin nito, yun nandito, ito yung greater than, right? Greater than 1.84. Ito yung less than 1.84. Ito yung sa greater than 1.84. Okay? Anong mangyayari pag pinag-add natin yon? Less than, tsaka yung greater than, yung probability. Anong mangyayari? Anong makukuha nating sagot? Anong property ng ating normal distribution curve? Yung standard normal distribution curve natin, ano yung property? The total area below it is equal to 1 square unit equivalent to a probability of 1. So, sabihin yan, 1 ang sagot pag pinag-add natin. Therefore, ito ay 1 minus probability that z equals less than 1.84. No? Kasi hinahanap natin ito eh. So, transpose natin sa kabila yon. Transpose natin sa kabila ito. Okay, kasi 1 yan eh. Lagay ko dito yung 1. Ayan. 1. So, transpose natin sa kabila ito. So, 1 minus probability z less than 1.84. Z is less than 1.84. There, no? So 1 minus P, 1 minus the probability that Z is less than 1.84, no? So sabihin nito, area to the right is equals to 1 minus area to the left. Yan. Okay? So ito siya. Exactly, right? So, ang sagot ay ito. Ito yung 0.9671. Okay, yung 0.9671 na to ay area to the left na makukuha natin sa table. Pakita ko yung table. Okay? Pakita ko yung table. Huwag niyo munang isipin to, no? 0.9678 0.96 0.96 tingnan natin yung 1.84. Tingnan natin yung 1.84. 1.84. Okay. To the left. Area to the left, 1.84. Ito 1.8. At tapos 1.84. Ito. Hindi ito 1.84. 0.9671. Ito. Area to the left yan. 0.9671. 1.84. Okay. Ayun. So 0.9671. 1.84. Ayun. 0.9671. Ayun. 0.9671 siya, no? So, ang sagot ngayon ay 0.0329. Ito yung area to the right. 0.0329. So, therefore, the area is 0.0329 square unit. No? 0.0329 square unit. That's it. No? Ganun lang kasimple. Next, between z negative 1.927 and z 0.86. So, z negative 1.97 and z equals to 0.86. Ayan. Ngayon, para masagot yan, solution yan ay ito. From table 8.3, okay. So, ano yung area to the left? Kukunin natin yung area to the left ng negative 1.97 dun sa table 8.3. No? So, tapos kukunin din natin yung area to the left nung 0.86. No? So, from table 8.3, no? Kukunin natin yon. So, ang hinahanap natin ay itong probability na to, that the random variable z, ito, is in between negative 1.97 and 0.86. Ano yung probability na in between siya ng negative 1.97 and 0.86? Okay? Greater than negative 1.97 but less than 0.86. Okay? So, in that case, no? Para ma-solve natin, paano natin masasolve? So, ito yung hinahanap natin. So, ang gawin natin, yung area to the left ng 0.86, i-minus natin sa area to the left ng negative 1.97. Makukuha natin yung area na to sa pagitan ng negative 1.97 and 0.86. Gets nyo? Okay? Kasi, ito yun, o para mag-gets nyo pa. So, ito yung ating graph. Ito yung 0.86, right? Kung ito yung 0.86. Okay. 0.86. Ayan. Area to the left niyan. Okay? Mula negative infinity hanggang 0.86. I-minus natin dito. Yung negative 1.97 nandito. Negative 1.97. Ayan. I-minus natin yung area to the left. from negative infinity to negative 1.97 equal to, ano yung equal niyan? Equal sa, ito, ayan, yung mismong area na yan. Okay, yung naka-shade. So, area to the left ng 0.86 minus area to the left ng negative 1.97 equals yung area ng remainder, which is from negative 1.97 to 0.86. So, paano natin nire-represent to? In terms of probability. So, ito, probability that the random variable z is less than 0.86. Kasi area to the left. Ito naman yung probability that the random variable z is less than negative 1.97. Okay? I-minus natin. Tapos, ang resulta, ito. Probability that the random variable z is between negative 1.97 and 0.86. So, ito siya. No? Minus ito. So, kung gagamit tayo ng table, 0.8051 ang makukuha natin. Less than 0.86, 0.8051. Sa negative 1.97 naman, 0.0244. So, ang sagot ay 0.7807. Okay? So, ito siya. Para lubusan yung makita. Or should I say maintindihan? So, tignan natin yung 0.86. Area to the left, 0.86. 0.86. Ito, 0.886. 0.86. Ito, 0.8051. Kaya, ayun, 0.8051. Negative 1.97. Tignan natin, negative 1.97. Ito, negative 1.97. 0.0244. Ayun. Okay. There, 0.0244. Don't worry, I'll provide you the presentation as well as the table, no? Although pwede naman downloadable naman to sa internet yung table na to, no? Okay. So we can proceed. So the answer is 0.7807 square unit. Alright, so we now proceed with problem 2. Okay. Problem 2. Given a standard normal distribution, find the value of k such that the probability that the random variable z is greater than k is equal to 0.315 and the probability that the random variable z is greater than k but less than negative 0.18 is equal to 0.4197. Okay, so let's analyze. So we are to determine the value of k such that the area to the right is 0.3015. No? So sabihin nito, interpretation ng probability na to na greater area to the right. So ito ay 0.3015 na area. No? So ito ngayon yung k. K. So ito yung k. And then, ito yung area to the right, 0.3015 square unit. So the probability that the random variable z is greater than z. So ito yung formula natin. Equal to 1 minus probability that the random variable z is less than z. In short, area to the right is equals to 1 minus probability area to the left. No? Bakit natin ginagawa ito? Kasi ang given sa table natin, dun sa table 8.3 ay area to the left lagi. Wala tayong area to the right. Therefore, tayo mag-a-adjust. No? So then probability that the random variable z is greater than k is equal to 1 minus probability that the random variable z is less than k. Kasi, so, ito yung malit na z. Okay, na equal sa k ngayon. Okay? So, in here, we have, naulit lang. Ay, hindi. Inano natin. Pinagpalit natin ng posisyon, no? Pinagpalit natin ng position. Okay, probability that the random variable z is less than k is equals to 1 minus probability that the random variable z is greater than k. Okay, pwede naman pagpalitan ng position. So, ang goal natin ay makuha yung k, right? Given na kasi itong probability. Ito yung probability that the random variable z, ito, is greater than k. Okay? Kaya, ganito yung ginawa natin. Tin-transpose natin. No? Ito yung 0.3015. So, bibigyan na yung sagot ngayon. 0.6985. Ito na yung 0.6985. Ngayon, yung puti. No? Ngayon, gagamitin na natin yung table para mahanap yung K. So, baliktad naman ang gagawin natin. Given yung area, hanapin yung value ng Z doon sa table. Given yung area na to the left na 0.6985. Okay. So, ang sagot dyan ay 0.52. Verify natin, no? Kung 0.52. Verify natin kung 0.52. 0.6985. Hanapin mo yung area na 0.6985. Area to the left na yan. So, manap ka ng 0.6985 dito. Ito, 0.6985. 0.6985. Ito, 0.6985. Saan ba yun? Ito. Ano yan? 0.5 at saka 0.02. So, sabihin yan, 0.52. 0.6985. 0.52. Okay? So, yun yan. 0.52. Okay? Hanapin mo yung area. Then, mahanap mo na yung Z. So, yung Z dito ay 0.52 which is equals to K na 0.52. No? So, that's it. Okay, so we proceed. So, letter B naman tayo. Ito yung letter B. Letter B naman. Given a standard normal distribution, find the value of k such that b, the probability that the random variable z is greater than k but less than negative 0.18 is equal to 0.4197. So, ang interpretation niyan, ito yung lower value, ito yung higher value. So, lower, higher. Okay? Kasi less than eh. Sabihin niyan, z is greater than k, lower. Z is less than negative 0.18. Higher yung negative 0.18. So therefore, pagkakasulat, nandito yung K, nandito yung negative 0.18. Nasa left yung K, nasa right yung negative 0.18. At tapos, in between, may area, no? So yung Z ngayon, in between ng K at negative 0.18, merong ganitong area. So that is equivalent to 0.4197 square unit. Ang interest natin ay malaman yung K. So what is K? So hanapin natin sa table yung K. So note, no, the probability that the random variable z is greater than a but less than b is equals to, wait lang ba't merong ganito? Correct ko lang. is equals to, ayan, ayan. So probability that the random variable z is greater than a but less than b is equals to probability that the random variable z is less than b minus probability that the random variable z is less than a. So pagka dalawa yan, okay, a less than z less than b, sabihin yan, area to the left nito minus area to the left ng isa. Area to the left nung may higher value minus area to the left nung lower value. So, area to the left ng negative 0.18 minus area to the left ng k. Para makuha mo itong area na yan. Yung kulay yellow-green. Okay? So, in that case, we have, so A is k, no? B is negative 0.18. So, we have B is negative 0.18, A is k. And then, so we have P, Z greater less than K. Ito ngayon, probability that Z is less than negative 0.18 minus probability. So, pinagbaliktad natin yung position. Kasi ang goal na, kasi ito yung given eh. Ito yung given. 0.4197. So, ano yon? Ito yon. Yung 0.4197, right? Kasi ito na yon, 0.4197, right? So, transpose natin. Anong goal natin kasi? K. So, ito yung ita-transpose natin sa left side ng equation. So, kaya ito siya ngayon. No? And then, ito, malalaman natin sa table. Z less than negative 0.18. Ito. Minus ito. K. Ito yon. Ito yung transpose natin. So, ano to ngayon sa table? Negative 0.18? 0.4286 based from the table. Table 8.3. Ito, given na sa problem, 0.4197. So, ang bibigay na sagot ay 0.0089. Area to the left. O, ngayon, tingin tayo sa table na may area, tapos malalaman natin yung Z doon sa table. Yung Z doon sa table, yun yung K. Okay? So, ang K from table 8.3, ang K natin ay negative 2.37. Check natin. Dito muna tayo kung paano nakuha itong 0.4286. Tignan natin yung negative 0.18. Negative 0.18. Negative 0.18. Ayan, negative 0.18. Ayan, negative 0.18. Ito, 0.4286. No? Negative 0.18. 0.4286. Okay? Tapos, 0.0089 na area. Hanapin natin. 0.0089. 0.0089 area. Area to the left, 0.0089. Kasi yung Z less than K, area to the left yan eh. So, dito sa table, 0.0089. Ito. Ano yan? Negative 2.37. Negative 2.37. Okay? Ayun. Okay? So, we proceed, no? So, next, we have so number 3, given a random variable x having a normal distribution with mu equal to 50 and sigma equals to 10, find the probability that x assumes a value between 45 and 62. Okay. So, ito yung ating random variable x. Okay? Meron siyang normally distributed siya. So the mean is 50. Okay? The mean is equals to 50. Ito. Ang standard deviation ay 10. Okay? And then, find the probability that x assumes a value between 45 and 62. So, ito yung ating 45, ito yung ating 62. So, ito ngayon yung ating hinahanap. The probability that x assumes a value between 45 and 62. Okay? So, ito yung probability that x is greater than 45 but less than 62. So, recall natin that ito yung transformation formula kung paano yung normal random variable x ay gagawin nating standard normal random variable z. Okay? So, from x to z, at yung transformation, para yung normal distribution na to ay maging standard normal distribution. So, x minus mu over sigma. Gawin natin. So, consider muna natin yung unang value ng z, yung maliit na value, 45. X sub 1 is 45. Okay? Ito yung ating x sub 1. Kasi ito yung ating random variable x. Ito yung x sub 1, ito yung x sub 2. Okay? So, ito ngayon. So, x sub 1 is 45. Ang mean natin ay 50. Ang sigma natin ay 10. Ang sagot ay negative 0.5. Likewise, x sub 2 ay 62. So, 62 minus 50 over 10, 1.2. So, ito ngayon yung magiging transformation. Ito na yung bagong normal distribution. Standard na siya ngayon. So, yung mu naging 0. Ano ulit? Ang property ng standard normal distribution? Standard normal distribution is a normal distribution having a mean of 0 and a standard deviation of 1. Okay. So, in this case, this is 0. And we have negative 0.5. So, ito yun. Yun to the left, negative 0.5. Tapos, yung z sub 2, 1.2. So, sabihin niyan, yung 45. So, naging z1 siya doon. Yung 45 naging negative 0.5. Yung 62 naging 1.2. So, ito yung z2 natin. Okay? So, this is now. So, itong probability na to, 45 less than x less than 62, naging probability that the random variable z assumes a value between negative 0.5 and 1.2. Okay? So, magagamit na natin ngayon yung table 8.3. Kasi applicable lang ang table 8.3 kapag standard normal distribution. No? So, kailangan i-convert muna natin yung distribution na to ng standard normal distribution. No? So, in that case, we have this formula, okay, between the two, area to the left minus area to the left. Area to the left of the higher value of z minus area to the left of the lower value of z. So, and then, using table 8.3, ito yung magiging result. 0.8849 minus 0.3085. Okay? So, alam nyo na yun and I don't need to elaborate kung paano nakuha yan. So, alam nyo na sigurong gamitin yung table. Okay? And then, the answer is 0.5764. Okay. Now, number 4. Given that x has a normal distribution with mu 300 and sigma 50, find the probability that x assumes a value greater than 362. Okay, recall natin. That is z equals to x minus mu over sigma. So z is 362 minus 300 over 500. So ang x natin ay 362, right? Assumes a value greater than 362. No? So kung i-illustrate natin, okay, ito yung 362. Ito yung 300. 300 muna. Ito yung 300. Yung gitna. Yung mean Ayan yung mean. Tapos, meron daw standard deviation na 50. 362 nandito. Okay. Ayan. Ito yung x natin, random variable. Assumes a value greater than 362. Mataas daw sa 362. Ano yung probability na yan? No? So, gawin muna natin siyang standard normal distribution. So, kaya, okay na siya, 1.24. So, yung 362, naging 1.24 na z. Okay? Yung mu na yan, z0 yan. No? 0. Okay? And then, alam niyo na yan. So, then, ano yung 1 minus probability? Z less than 1.24. Using table 8.3, 0.8925. No? And ang sagot natin ay 0.1075. Okay? So that's the answer. So that's our answer. Yan yung sagot, no? So probability that x is greater than 362 is equals to the probability that z is greater than 1.24 is equals to 0.1075. There. So that is our answer. Okay, problem number 5. Given a normal distribution with a mean of 40 and standard deviation of 6, find the value x that has letter A, 45% of the area to the left, and letter B, 14% of the area to the right. So let's analyze. So we have a normal distribution. So this is the normal distribution. And we have here a mean of 40 and standard deviation of 6. And we are to find the value x that has 45% of the area to the left. No? So we know that from negative infinity until we reach the mean, no? From negative infinity to the mean, that is about 50% of the total area. So in other words, the value of x is below the mean, no? The value of x is below the value of the mean. So we are to expect the value of x to be lower than 40 because the mean is equals to 40. Okay? So this is now 45%. Therefore, this represents the probability that our random variable x is less than this value x that we will determine, no? And that is equals to 0.45. Okay, representing the area of 45%, no? Area for the total area, 45% of the total area. Now it represents. Okay, so in here, let us solve for letter A. To solve for x, okay, so we will let probability that the random variable x is less than a specific value x equal to the probability that the random variable z is less than a specific value z, a lowercase z, no? So, in other words, we are to change the random variable x to random variable z. So, we know that the random variable x is used for a normal distribution. The random variable z is used for a standard normal distribution. When we talk about standard normal distribution, again, it is a normal distribution with the mean of 0 and standard deviation of 1. Okay, so upon doing this, so we know this is 0.45, we can able to use table 8.3. Okay, so if we are to use table 8.3, z is equals to negative 0.12 for this probability that the random variable z is less than a specific value z, which is found in the table 0.4522. That is negative 0.12. No? So if you are to search for this on the table, in the table we are to search. This is 0.4522, and this will give us a value of z of negative 0.12. On the other hand, we can also, from the table, we can also see 0.4483. That will give us a z of negative 0.13 based from the table. No? So there's no exact 0.45 in the table. No? So there's no exact value of 0.45 in the table. So, so what shall we do now? So we can approximate. So we can get the average. We can get the average of the two, negative 0.12 and negative 0.13. That will give us negative 0.125. In other words, we are to add negative 0.12 plus negative 0.13 all over 2. That will give us negative 0.125. And this will now be, so this is now the value of z for a probability equal to 0.45. Okay, which is equals to probability that the random variable x is less than the value x, which is 0.45. So now our concern is to find the value of x. No? Our concern is to find the value of x. Given we have the value of z, we can transform it to x, recalling the formula. Z is equals to x minus mu over sigma. So this is our transformation formula. No? Z in terms of z, we can express x in terms of z and vice versa. So in here, we have z, and we can able to find for x now because we have z, we have also the mean, and we have the standard deviation. So rewriting the formula, we have x is equals to mu plus z sigma. Okay, this will now be the equivalent, or okay, we have transformed the formula in terms of x. Okay, so in this case, we know the mean is 40. We just substitute. We have the value of z of negative 0.125, the value of sigma, which is the standard deviation of 6, giving us a value of x of 39.25. So this will now be our final answer, 39.25. Okay, let me show you how did we arrive with negative 0.12 and negative 0.13. So we are to locate 0.45 from the table, which is an area, no? So which is an area. So locating, okay, 0.45 we have here 0.45. There's no exact 0.45 in the table, right? So we have here 0.4522 and 0.4483, right? This is 0.45. This is an area to the left, right? 0.4522, 0.4483 in between the two. So 0.4522 is equals to is has a value of z equal to negative 0.12, no? So negative 0.12. So this is zero point zero 0.01, zero point zero 0.02. So we have negative 0.12. So negative 0.10, negative 0.11, negative 0.12. So 0.4522. Okay? And then we have 0.4483. We have negative 0.13. So this is 0.10, 0.11, 0.12, 0.13, negative 0.13. So 0.4483. Okay? So and then we can get the average, no? So we have negative 0.125 for a probability equal to 0.45. Okay? So that's it. So we now proceed to letter B. Okay? We now proceed to letter B. B, 14% of the area to the right. So this time the probability that the random variable x is greater than a specific value x. So to solve for x, we let the probability in terms of the random variable x be equal to the probability in terms of the random variable z. So that is area to the right. Now using table 8.3, this is the area to the left, 0.8599. Now this is 0.855, 0.8599. This is area to the right, based from table 8.3, which concerns about area to the left. So this is the notation for area to the left. So we will get 0.8. So that's about 0.8599. No? So this is 0.14. Therefore, probability that the random variable z is less than z is 0.86, right? So probability that the random variable z is less than z is 0.86. Okay? So let's locate 0.86 from the table. So locating 0.86 from the table will give us a value of z of 1.08. So therefore, since there's no exact value of 0.86 from the table, okay, this is estimated to be the value of z, okay, 1.08, because there's no exact value of 0.86 from the table. So this is about 1.08, okay? Okay, and then knowing 1.08, so we can transform it in terms of x, and will give us an answer of 46.48. Okay, so let's see. So we have 0.86. See, this is 0.14 area to the right. We have 0.86 area to the left. Okay, 0.86. So that is 1 minus area to the right is area to the left, which is 0.86. So let's locate 0.86. 0.86 area, 0.86 here, 86, sorry, 86. So we have 0.8599 and 0.8621, right? In between the two, right? The value of 0. An exact value of 0.86 is in between the two values, no? So we will use 0.8599, which is nearest to uh, nearest to 0.86. So the value of z here is 1.08. This is 1.08. Okay, so 1.0 plus 0.08, 1.08. So this is 1.08. Okay, so z is 1.08. Okay, that's it. Alright, so we now proceed. So number 6, a certain type of storage battery lasts on average 3 years with a standard deviation of 0.5 year. Assuming the battery life is normally distributed, find the probability that the given battery will last less than 2.3 years. Okay, so let's analyze. So the mean is 3 years. Okay, 3 years. The standard deviation 0.5 year. Okay, and then so this is the graph, the normal distribution, graph of the normal distribution. So we have the value of x. So as you notice, we are to determine the probability that the given battery will last less than 2.3 years. We know that the average is 3 years. Therefore, we are to expect that the area will be uh, less than 50% because the mean is 3 years, while from the problem we are to determine the probability, so that's the area, that the given battery will last less than 2.3 years. So less than 2.3 years, which is below the mean. 2.3 years is below 3 years, right? So it's below the mean. So this is now our concern. Okay, x is 2.3 years. Okay, and in this case, what is this probability? Okay, so to answer the problem, so we let the probability in terms of the random variable x be equal to the probability in terms of the random variable z, and we know the conversion, and doing that we can able to determine z. Okay, and this will now be the answer, negative 1.4. Okay, and we using table 8.3, so this will be 0.0808. So this will be our answer. Okay, so this will be our answer for the probability. Okay, so since the two are equal in terms of the random variable x and in terms of the random variable z, therefore the probability that the random variable x, which is the concerning the number of years that the battery will last, no? uh, will last less than 2.3 years. No? So what is that probability that the battery will last less than 2.3 years? So the random variable x less than 2.3 years. So that is 0.0808. So that is our final answer. Okay? So that's the probability that the battery will last less than 2.3 years. 0.0808. So in other words, there's an 8.08% chance that it will last less than 2.3 years. So 8.08% chance that the battery will last less than 2.3 years. So mababa lang yung chance na yon na mangyari yon. Okay? So, yun yung ating sagot. No? So number 7, an electrical firm manufactures light bulbs that have a life before burnout that is normally distributed with mean equal to 800 hours and a standard deviation of 40 hours. So we have the mean of 800 hours, standard deviation of 40 hours. Find the probability that a bulb burns between 778 and 834 hours. So in between the two. Okay? So, ano raw ang tsansa na yung bulb ay uh, ma magiging defective na, in short, no? Or should I say, ma-reach na yung kanyang lifespan. Ma-reach na yung kanyang, maano na siya, mapundi na, ne? Madane. And mag-give light, no? So that a bulb burns between 778 and 834 hours. So in that case, what's that probability? So solution, no? So ang average ay 800 hours, yun ang mean, di ba? So mean. So yun ang mean equal to 800 hours. So normally, okay, bago bago mamatay yung bulb, okay? So ang average rate is 800 hours. So ngayon, given yung case na yan, ano raw yung probability na mamamatay yung bulb between 778 and 834 hours. No? So let's solve. So we are to consider first the first value of the random variable x, which is 778 hours. We represent it in terms of the random variable z. Will give us an answer of negative 0.55. Then we proceed with finding the random variable, finding z sub 2, okay, using the second value of x, which is 834 hours, and will give us an answer of 0.85. So this is now our solution. So the probability that the random variable x, okay, is between 778 hours and 834 hours is now equal to the probability that the random variable z is now between negative 0.55 and 0.85. So recall, so the probability that the random variable z is greater than z sub 1 but less than z sub 2, that is equal to the probability that the random variable z is less than z sub 2 minus probability that the random variable z is less than z sub 1. So in other words, no, area to the left of z2 minus area to the left of z1. Okay? So doing that, so we have negative 0.55 and 0.85. So this is 0.85, c sub 1 negative 0.55. So we have an answer of, now, based from the table, so probability that z is less than 0.85, we are to locate z sub 2 in table 8.3. And that will give us 0.8023. Okay? Likewise, for z less than negative 0.55, we are to locate z equals to negative 0.55 in the table. That will give us 0.2912. Okay? And then this will now be our answer, 0.5111. Okay? So, therefore, the probability that a bulb burns between 778 hours and 834 hours is equal to 0.5111, meaning there is a 51.11% chance that a bulb burns between 778 hours and 834 hours. Okay, so that's it. So we now proceed with number 8. Number 8, a certain machine makes electrical resistors having a mean resistance of 40 ohms and a standard deviation of 2 ohms. Assuming that the resistance follows a normal distribution and can be measured to any degree of accuracy, what percentage of resistors will have resistance exceeding 43 ohms? Okay, so let's answer. So we have given a mean of 40 ohms and a standard deviation of 2 ohms. Assuming that the resistance follows a normal distribution. Okay, so we are to determine now percent of resistors that will have a resistance exceeding 43 ohms. Percent of resistors that will have resistance exceeding 43 ohms. Okay, so that is our concern. No? So since this is our concern, this is just the same as finding the percent probability. No? So the probability in terms of the percent form, in percent form. Okay, so the probability that there are random variable x is greater than 43 ohms. Okay, so our random variable x here is the resistance of a resistor. No, so what is now the probability that the resistance exceeds 43 ohms? No, so in that case, we are to determine first the probability that x is greater than 43 ohms. Okay, so to do that, so we use this formula again, transformation formula from x to z. So we have 43 ohms, okay, and then 40 ohms, okay, 43. Because according to the problem, what percentage of resistors will have resistance exceeding 43 ohms? No? So if that is our concern, percentage of resistors that will have a resistance exceeding 43 ohms, so meaning, kung meron ako normal distribution curve, yung area to the right, kasi exceeding exceeding 43 ohms. So yung area na yon, kung ilang percent man ng kung ilang percent man yon, yung area na yon, sa kabuuang area kung ilang percent yun din yung percentage of resistors that will have resistance exceeding 43 ohms. Okay? So in that case, we have 1.5 Z. So Z is 1.5. Okay? So in that case, so we are to determine the probability that X is greater than 43 ohms. Okay? We are to determine that the probability that X is greater than 43 ohms. No? Ano yung probability na yung isang resistor ay mataas pa sa 43 ohms yung kanyang value? No? Ano yung probability na yung resistance ng isang resistor ay mataas pa sa 43 ohms? So, convert natin in terms of standard normal distribution. Ito yung random variable niya. So, greater than 1.5. So, yung 43 ohms, naging 1.5. We can now use the table. But before we can use, this is area to the right. We are to express this in terms of area to the left. No? Kasi sa table, area to the left. So, we have this conversion. So, area to the right equals 1 minus area to the left. No? Then, so, alam natin that this probability, x greater than 43 ohms, is 1 minus, ay equal dito, di ba? Probability that z is greater than 1.5. So, ni-replace lang natin. Okay? So, ni-replace lang natin. Kasi equal yung dalawa eh. Right? So, kung ito yung ating basihan, okay, kung yan yung ating basihan, therefore, i-replace natin ito ng ito, x greater than 43 ohms na equal dito ngayon. 1 minus p, z less than 1.5. Ayun. Okay? So, ganun siya. So, z less than 1.5, area to the left, ito area to the left, hanapin mo lang yung z na 1.5 sa table, 8.3. Bibigay niyang sagot, 0.9332, yung table. Okay? So, yun ang sagot. At bibigay niya ay, final answer ay 0.0668. Okay? X greater than 43 ohms. So, ibig sabihin yan, kada resistor, ang probability na yung resistance kada resistor ay mag-exceed ng 43 ohms ay maliit. 0.0668 lang. Sabihin, 6.68% ang chance na kada resistor ay mag-exceed ng 43 ohms yung kanyang resistance. No? Ngayon, yun din ang sagot natin sa problem. Yun din yung percent ng resistors na mag-exceed ng 43 ohms. Okay? Yun din yung percent of resistors that will have resistance exceeding 43 ohms. Yun din yung area to the right. So, yung area to the right, no, ay ito lang siya. So, yung area na yan ay 6.68%. Okay? Ito yung 43 ohms natin. Okay? So, therefore, percent of resistors that will have resistance exceeding 43 ohms is 6.68%. Okay? 6.68%. So that's it, no? Okay? So we now proceed. So number 9. Find the percentage of resistances exceeding 43 ohms. For example 8, if resistance is measured to the nearest ohm. So dito, resistance is measured to the nearest ohm. No? Anong ibig sabihin nun? Resistance is measured to the nearest ohm. Halimbawa, 43 ohms. Round off natin, 43 ohms. Okay? Kung halimbawa, meron akong another resistance. 43.1 ohm. Lumampas ng 43 to, right? Pero sabi dito, measure to the nearest ohm. So, sabihin, measure to the nearest ohm. Consider natin yung pag-round up or pag-round down. Kasi i-measure natin to the nearest ohm. So, in other words, approximately 43 ohms. 43.1 is approximately 43 ohms. Kasi measure to the nearest ohm. Kung meron naman akong 43.4 ohms, that's about 43 ohms pa rin, right? Round down pa rin. Kaya kung 43.49 ohm, that's about 43 pa rin. Kaya kung 43.5, ayun, 44 na siya. So, measure to the nearest ohm, ayan. So, nearest ohm, 43.5, so 44. Okay, 44. Okay, unlike yung kanina, so balikan natin. Measured to any degree of accuracy. Any degree of accuracy, ibig sabihin yan, including decimal. Okay? So, ibig sabihin, 43.01 ohm, mataas na yun sa 43 ohm. Kasi measured to any degree of accuracy. Okay? So, pagdating naman sa number 9, okay, measure to the nearest ohm. Okay, consider natin yung ones place, tapos yung decimal nun, pagkatapos ng ones place, round up or round down natin. Okay? So, we now proceed. So, given, the mean is 40 ohms from example 8. The standard deviation is 2 ohms. We are to determine the percent of resistors that will have resistance exceeding 43 ohms. No? Pag sinabing exceeding 43 ohms, kasama na yung 43.4 ohms. Sorry. Exceeding 43 ohms, sabihin niyan, kung measure to the nearest ohm, exceeding 43 ohms, sabihin niyan yung 44 ohms and above. No? 44 ohms and above. So, kung 44 ohms and above, i-consider na rin natin yung 43.5 ohms. Kasi, i-round up natin yan. Magiging 44 na yan. Okay? Consider natin din yung 43.5 ohms. Okay? Exceeding 43 ohms na yun. Okay? Kasi we consider measuring the resistance to the nearest ohm. So, ito yung ating concern ngayon. Percent of resistors that will have a resistance exceeding 43 ohms. Okay? Malalaman natin yan. Okay? Pag ginawa natin yung percent in terms of percent nitong probability that the resistance of every resistor is greater than or equal to 43.5 ohms. Okay? Ibig sabihin yan, 43.5, 44 na yan. Diba? 43.5. So, greater than or equal to 43.5 ohms. 43.49 or 43.4, 43 pa rin yun. Okay? Dahil sabi dito, measured to the nearest ohm. Okay? So, 43.5, 44 na yan. Okay? Measured to the nearest ohm. So we proceed. So, solution. Ito yung ating formula. Transformation of x in terms of z. So, consider ngayon natin sa problem 8, ito ay 43, dito 43.5 na siya. Okay? 43.5 na siya. Okay? So, in that case, 43.5 minus 40 over 2. Note, note, okay, probability x greater than or equal to 43.5 ohms. 43.5 ohms equal yan dito. Greater than, pwede na. Greater than 43.5. Kahit whether meron siyang equal sign, meron siyang sign of equal or wala, pareho lang. Because the probability that x is exactly equal to 43.5 ohms is 0. Why? Because this is a normal distribution, which is a continuous probability distribution. Pag sinabing continuous probability distribution, ang probability na yung random variable x ay exactly equal sa isang value ay 0. No? In my previous discussion, nabanggit ko yan. Okay? Kaya, whether may equal sign or wala, no? Greater than or equal to, or greater than lang, pareho lang yun. Okay, so we now proceed. So z is 1.75. Okay? So in this case, ito yung ating sagot ngayon. So probability x greater than or equal to 43.5 ohms is now equal to probability that z is greater than or equal to 1.75. Recall natin, this is area to the right. So express natin in terms of area to the left. Okay? Setting solution. So meron tayo nito. Palitan lang natin ito. Okay. Ito. And then, magre-remain dito. No? Yan. Okay? And then, we substitute now. So, this is area to the left. And yung area to the left na yan ay based from table 8.3. Hanapin natin yung z na 1.75. Okay? So, at z equal to 1.75. Okay? So, ang bibigay na sagot ay 0.959. 0.9599. Okay? Yun ay base sa table. No? Yun ay base sa table. Okay, so what's now our answer? So 0.0401. So that is our answer. Express natin in terms of percent. Multiply natin ng 100% ito. 4.01%. So sabihin niyan, 4.1% of resistors will have a resistance exceeding 43 ohms. Okay? So 4.01% of resistors will have a resistance exceeding 43 ohms. considering measuring resistance to the nearest ohm. Okay? Yung kanina, considering measuring resistance to any degree of accuracy, mataas yung chance, 6.68%. O mataas yung bilang ng mga percentage ng mga resistors that will have a resistance exceeding 43 ohms kasi kinonsider natin yung pati 43.1 ohms, 43.2 ohms, basta greater than 43. Pero pagdating to the nearest ohm, yung 43, yung below 43.5 ohms, hindi natin i-consider yan. No? Kaya 4.01% lang ang lumitaw. Okay? So, yun siya. I hope you get it. Sana naintindihan nyo. So, this is our answer, 4.01%. Alright, so 4.01%, okay, 4.01% of resistors will have resistance exceeding 43 ohms if resistance is measured to the nearest. So that's it. So I hope you get it. So good day everyone.